Hello, everyone. My name is Robert Ronan. I'm a Principal Product Manager with the OCI Developer Cloud Adoption Team. Thank you for attending today's webcast, and thank you to Tara Van Cleve for putting all this together. We have an amazing presentation from the RackWare team. We have Aniket Kulkarni, Senior Director of Development. If you have any questions during today's session, please put your question into the Q&A area. We will have a live Q&A session after the presentation. Before I hand things over to the RackWare team, I'd like to direct your attention on how to get started with Oracle Cloud. We offer an always free tier, which the services in this tier are offered for an unlimited time at no cost. In addition to the free tier, you can also ramp up with a 30-day free trial. This includes all services and the services that are included in the free tier. If you want to learn more about developer events hosted by Oracle, here are a few links and resources. Feel free to email me at robert.ronan@oracle.com. And we invite you to take a super quick one-question survey after the presentation to let us know how we're doing. And with that, I'd like to hand things over to the RackWare team. Aniket, it's all yours.
Hello everyone, my name is Aniket Kulkarni. I work as a Senior Director of Development for RackWare. I'm leading development of backup, migration and DR solutions for container environments. Now before we start with today's webinar topic, I just wanted to give some background on RackWare. RackWare is a leader in migration, backup and DR solutions. We are in this domain for almost a decade now. RackWare is headquartered in the US. We have main headquarters in San Jose. We have multiple offices in the US as well as India. We are like 60 plus team. Now coming to the today's topic, we will look at DR as a service solution for Oracle Kubernetes Engine, that is OKE Cloud. We'll also look at the quick demo where we'll launch the solution from Oracle Marketplace and set up a DR for a test application. And that will show how easy it is to do it. Now some highlights of this DR as a service offering. It's based on the OCI Marketplace. Essentially, it's a DR subscription. It is using RackWare Swift product internally. Now RackWare Swift is our latest offering for container migration, backup and DR. And I'll give you some insights on how RackWare Swift works and some technical overview. That way demo will also make a lot more sense. It's a DR subscription, so it's like a pay-as-you-go service. You just start this subscription from Marketplace, launch Swift appliance in your OCI account, and start using solution in minutes. And we'll look at that in today's demo. We do have migration subscription as well as bring your own license offers there too. And if you're interested, you can go ahead and try BYOL offering, which allows you free migration of 2 microservices up to 400 GB of data. We did do a webinar on migrations for one of the other Kubernetes clouds to Oracle Kubernetes Engine, OKE Cloud. And we'll link that webinar recording as part of the today's webinar description later. So do check it out if you are interested in that. Now with Swift, the vision is to allow any-to-any container migration, backup and DR. We do support multiple Kubernetes clouds and platforms. We also support OpenShift. So essentially you can migrate from any of these clouds, Kubernetes clouds or OpenShift or Kubernetes on-prem to OKE and also set up DR. One interesting observation we have for container domain is that the cross-cloud DR is a reality. That never happened for VM or physical servers, and especially if cloud is in the picture. But that has become reality definitely with container-based application deployments. So Swift will allow you to do that. So you can use any combination like on-prem production and OKE as a DR, then both production as well as DR in OKE. We do have customers who want to use OKE as a production and then DR because of some compliance reasons in their the on-prem. So you can do any of those combinations. Swift runs as a standalone appliance, so it gives you single pane of management. So that actually brings me to, what are the differentiators for this solution in general, like, DR as a service, which we are offering for OK Cloud. So the first and foremost is it's any to OK. So you can pretty much take any Kubernetes cloud, migrate from there to OK and set up DR within OK, or you can basically have any of the platforms or the combinations possible out there. Do this with this solution, like, any of those platforms as source, and then any of the, the platforms as a target. We do support a lot of storage types as well, and I'll show that list in a moment. So what that allows is, like, help you break that storage vendor lock-in as well. We also support container registry migration and DR. Now, I'm not gonna show that in today's demo, but we will be publishing a few blogs, so do, subscribe, so check those out. We'll soon probably link those in today's webinar description as well when it gets published. So what this solution will allow you to do is then, any container registry replication too. So essentially you can set up DR policies for your on-prem container registry to OCI container registry for your DR. Overall, it's a hybrid sync mode. So what happens is, since product is running outside of your cluster as a VM, it has access to all clusters, so it has that larger view. So essentially, when it comes to your data, it has a view of your file system on your application data volumes. So it can do a lot of things, but it does the block sync. So what happens is, due to this hybrid sync mode, it has a lot of flexibility. Like, it can change volume size. Now that feature is not out there, but soon it will be available. So you can also do a lot of customizations, like, exclude certain volumes. It gives a lot of flexibility in that terms. We do support dynamic provisioning of your DR cluster. So DR cluster can be pre-provisioned and kept hydrated, where product keeps syncing your application from production to DR cluster, or that, comes up as part of a failover event. It could be for test. So both have advantage. Like, if you keep it pre-provisioned and hydrated, it helps with the faster RTO time. But if you trade RTO time with, like, cost saving, then it can allow you to do the solution, like, allows you to provision a DR cluster runtime. Now the DR provisioning is not yet available. It will be available in our next release. It should get then available in the DR as a service solution too. Overall, it's an app neutral solution, so you can have any kind of application. You can have Istio service mesh or any other console like service meshes. You can have standalone applications using database. You can have any number of microservices. So this solution will help you replicate everything. So technically, it's an app neutral solution. We do certain things to enable replication of complex applications like Istio service mesh, for example. But overall, it's an app neutral solution. It's also a highly customizable solution. We do support pre and post script or pre and post YAML. So whenever sync runs from your production application to your DR application, whenever it's replicating data, application objects, metadata, it can run pre and post script or apply pre and post YAML before and after operation. Also, it has REST APIs in case you want to do certain additional automation, that's possible too. And for this solution we are discussing in today's webinar, DR as a service, essentially it's a subscription service. We generally license based on microservices, how many microservices you are syncing or replicating, and then additionally on storage. But in this case, it's only based on microservices. So essentially, and I'll show that as part of demo. The subscription, when you subscribe to this OCI Marketplace offer, if you add one OCPU to, let's say, Swift server, which you deploy from that, it will allow you to do 10 microservices per hour for replication. And you can increase or decrease that quota by adding more OCPUs or vCPUs to your Swift VM, which you will launch from the marketplace listing. Now, I'm not going to do a lot of technical details in this session. I'm just going to give very high level overview of the solution. Swift runs as a VM or virtual appliance. You can run it on any CentOS, Oracle Linux, or Red Hat machine. In case of marketplace, it will run as Oracle Linux template in your OCI account. You launch it from OCI marketplace. Swift has access to all your cluster which you want to, manage through Swift. Essentially, at the least, you'll have your production cluster, your DR cluster, and you'll have storage configured with Swift. And this storage is going to be your OCI block storage, and that's where it's gonna store your application backups. Essentially, it's a backup and restore kind of solution. And what you see on the screen is essentially like a two-step things. So in first step, it's going to discover your source cluster, source application. You can do selective things. You can tell it like which applications you want to back up, and it will only replicate that. So in this first step, we call it a stage one. It will back up your application metadata that consists of your Kubernetes or OpenShift objects, and then your application volumes, as well as any other metadata that application has been using on the source side. And as part of the next step, which we call stage two, it's going to restore that backup on your DR cluster. Now you can do multiple backups per application. You can also configure the DR policy, and I'll show that in the demo, wherein it will do that recurring stage one and stage two. The interesting thing is you can do stage one and stage two with their own frequencies. You can just do the backup of your source application in the Swift, and then not even do stage two at all, or do stage two, say very less frequently. Like you may have application backups running for source, say every 30 minutes, wherein Swift will go ahead do stage one. So it will take application objects, your volumes, your container registries, back them up in the Swift storage, and then like stage two could be configured to restore every like end of the day, for example. You can also create a stage one only DR policies where it will only backup, and whenever failover happens, the failover could be for testing. It's gonna restore that to the target as part of failover by first provisioning the cluster. Now this picture is not yet available, but stay tuned for that. It will soon will be available. And we'll look at the demo where we'll do stage DR policy, which does stage one followed by stage two, and we'll look at all the options. Now, in terms of requirements, there are no such prerequisites. So essentially, Swift will run as a VM as part of your infra cloud in OCI. Typically, we recommend Swift to be run as part of your DR account, DR OCI account, or DR OCI region, because the production and DR cluster could be part of the same OCI account, but Swift should be in the DR cluster region. That's because if you lose source, you don't want to lose Swift. Optionally, you can run Swift in some third region, which is independent of your source and DR clusters. Swift is going to connect to the clusters on both sides. So you'll configure the clusters, which is like a very quick process. Within minutes, then it will go ahead and discover everything, find the dependencies between applications. The discovery process is instantaneous. It will just take few seconds. Then you select applications that you want to backup, configure DR policies for them, and it starts replicating. Connectivity wise, it needs only the network connectivity on both sides of cluster. It needs three ports. One is your API server connectivity to the Kubernetes, which is HTTPS port, and then it needs two ports from your Kubernetes or OpenShift service port range. Now these port ranges are where you will make your applications available to the outside world, which are running basically in the Kubernetes or OpenShift. You will make them available through these ports. Because what happens is during the replication time, it will run its transient pod. Our solution will run a transient pod. We call it a transient RackWare agent image try. So this try image sits in your container registry for the cluster, and then as during part of the sync, it will orchestrate running a pod in your respective cluster and create a microservice for this to access it from the solution. And it will use this pod as a staging environment. And what it does, it will take a backup of or snapshot of all the volumes your application using, which you asked it to replicate or backup. And it will attach those volumes, backup volumes, to this pod and use this as a staging environment to read the data. The first sync is going to be full sync, and any subsequent recurring syncs you do will only transfer the delta changes in terms of like a volume data. It's not going to recreate volumes in DR cluster every time you sync. It will only replicate to existing volumes and transfer the delta changes. It will recreate all the application objects. It will also replicate all the application objects when you restore or do stage 2. That includes your deployment sets, stateful sets, deployment configs in case of OpenShift, and then even like secrets, config maps, labels, everything. Basically, the application will look exactly same as source. Though said that, you can optionally do certain reconfig, like you can change service tags, you can do bunch of configs as part of replication. I'll just touch base on that during the demo. This is the product version matrix. We do support OpenShift and Kubernetes. Now, for this solution, OpenShift can be, say, your production on-prem, and you can use OKE as a DR, for example. In case of Kubernetes, we support 1.14 and onwards. And the older versions, of course, not available in OKE, but if, say, that's your on-prem, then you can still use that. In case of OpenShift, it's 4.5 and onwards. Third minor version typically doesn't matter for us. And we support a bunch of storage types for source, and I'll show that in a moment. And we also support all the public Kubernetes clouds. In case you want to move from there to OKE, you should be able to do that using either this solution or like our other offer, migration subscription, which is a migration as a service solution. Now, these are the storage types we support. I'm not going to spend a lot of time on this. This is just a list to show what all storage types we support for snapshot, because again, this is a backup solution. So we do have to take a snapshot of your Kubernetes application used volumes. And these are the storages supported for backing up. And again, you will see like, all the public clouds are supported. Also, we support Ceph. And if you have any storage type which we don't support already, we can add pretty quickly, because product is designed such way that we can basically enable any new storage type fairly quickly. Also, one thing to note here is we do support CSI as well as non-CSI variants, so we don't rely on only CSI snapshots. So CSI is the interface available in Kubernetes or OpenShift where storage providers can enable backup for their storage type. Now, not all storage providers support backup through their CSI driver. So good thing with this solution is that you should still be able to backup. We do support flex volume as well as CSI drivers. In case the storage type supports CSI driver and it has a backup enabled, then we'll use that, solution will use that. But if it's not, it will still do backup using the storage level integration for all the storage types you see here. Now, one thing I am not going to show in the today's webinar demo, but something I just wanted to highlight is that you have three parts to typical Kubernetes or container applications. You have your application metadata, which is your application objects in Kubernetes or OpenShift. Then you have your volumes, which consist of the application data. And the third is container images, which sit in the container registry. Now, the registries you see here on the screen, these are all supported for replication today now. So not only can move between these, like it will help you move images between these, but it will also allow you to set up like a DR between these registries. And Swift is the first and the only solution which allows you to set up a DR between your container registry. Now, why this is useful? Because typically for your production, let's say it's on-prem, you may be using Docker Hub or some Docker Hub for on-prem kind of variant, where your images are located, where your CI/CD pipeline or DevOps pipeline is spitting out images. Now, if your DR is set up now in OKE, you'll obviously want to use more cloud native solution, which is Oracle Container Registry. So of course, you need a tool to keep replicating images from your on-prem to OKE OCIR registry. The product will help you do that. It will allow you to set up DR policy. Now, though we are not showing it in today's demo, it's available out there in this solution, and it's not charged separately. It comes as a free solution along with main subscription cost. So you should be able to use that. And what we are planning to do is publish a few blogs around how you can use this, like a container registry replication as a service or registry DR as a service. So stay tuned for that. We'll probably link those blogs as part of today's webinar, recording. Now, most of this we already covered. So this is a subscription offer. So it's a pay-as-you-go solution. We do charge typically based on microservices. So the quota you get is based on OCPUs. So every time you deploy a shift from Oracle, marketplace listing, which is DR subscription, you will get 10 microservices for DR per hour. And if you want to increase or decrease that quota, just add or remove, OCPUs to your shift server. The billing for this is done as part of your monthly Oracle bill, so you don't have to pay us separately. It's part of your monthly bill. You will also get nice details like how much it's used and when it's used. If you don't need it, you can just decommission it, and this is fairly useful for migration subscription because there you just launch it, start replicating. Once you are done, just decommission it, and that's all. It's essentially pay as you go service. We do have a 24/7 support for this DR as a service solution. It's going to be email support because we have teams covering different time zones, so it's a 24/7 support. Our typical response time is just few hours, so you can expect quick responses to your query. Also, there is a free trial available with our Bring Your Own License offering. Again, I'm not going to show that. We already did a webinar last year. We'll link that. You can look at that, like how you can try out for free, like two microservices, move them to OKE, like do lift and shift kind of migration. Now we'll look at the DR as a service subscription demo, and this is a pre-recorded demo. In this demo, we are going to look at the test web application. We'll set up a DR for it between two OKE clusters. Both Oracle OKE clusters are running as part of same account, but in different regions. The production cluster is running in US West, while DR cluster is running in Germany Central. Both are using same versions, but Swift supports cross-cloud, cross-platform, as well as cross-version replications for DR. Also, in this case, though they are both using OCI block storage, I'll show during demo that you can actually choose what kind of storage you want to use during the initial application. Now let's look at both the production and DR environments. So what you see here is Oracle OKE cluster for the production, which is running in US West, and we have DR cluster which is running in Germany. Now we are going to use test blogging web application. It's based on WordPress. And to show that, what I have done is I have deployed the Kubernetes native dashboard for both production and DR clusters. Let me log into that. This is a production cluster. So there is a namespace called Blogger app. And you can see it has running bunch of pods, deployments, replica sets. So basically, it has two parts. One is database, and one is the actual core application, which is serving web pages. And that's running as part of deployment, while DB is running as part of stateful set, and both are running their own pods. Also, it's running load balancer service for main application for WordPress, and then the DB is running as like a cluster IP based service. It also has a bunch of config max and secrets along with two persistent volumes. And they're using OCI storage. Now let's look at the sample application. So I'll just connect to it. You can see it has a application blog there. It's a stage blog. Let me log into the admin interface. So and you see that like it has the blocks created, a couple of categories created. It has sample posts created. Now let's go to DR cluster dashboard, and now in this dashboard I created same namespace just to show that it has nothing running. It has bunch of default secrets created, Those are primarily for the Swift. This captures the credentials of the image registry where our try image, which is our transient pod image, is located, because Swift will orchestrate that image pod using this secret. And I'll show like how you create that. Now, since we looked at the primary and DR cluster and the application, now let's look at how you launch this DR as a service subscription. So this is Oracle Marketplace. If you search for Swift and say Kubernetes, you should see our listings. Now there are three listings. So you have migration subscription, DR subscription. For today's demo, we will use the DR subscription. And you can see that it's an hourly charged OCPU based subscription, and it allows you to do 10 unique apps or microservices per hour per OCPU. You can increase or decrease by adding more OCPUs to the SIP appliance. And you can essentially set up DR between any of them. Now we'll launch this. Let's click on Get App. So this will redirect you to the OCI Cloud account. We're going to launch it in a DR region of the OCI account, which will be Germany, Frankfurt, because that's our DR cluster is running. Because if you lose source region, you don't want to lose Swift. So Swift can be either in DR region or in some third region where it can access both source and DR clusters. So I'm gonna just launch the instance. You can look at the other details. So I'll just call it Swift DR instance, DRAAS. Change shape. It's Intel based CPU. And now I'm gonna pick this, which will since it has two OCPUs, it will allow you like a 20 applications or 20 microservices for application per hour, 20 unique microservices. I'll upload keys here. And the rest you can keep all the defaults. Okay, now Swift is running. Now let's add a block volume where it will store all the backups while Swift VM is getting ready. Let's do that. So I'll go to block volumes. I'll create a volume named Swift backups. And let's now this storage size need to be same as the application source application data. If it's a 1 TB, you'll add 1 TB volumes. You can do multiple volumes. Essentially, Swift will club these block volumes into one storage pool. It's a logical pool. You can create more than one pools too. But for this case, since there is not lot of data, I'll choose 50 GB as the size. You can also pick the backup of this backup volume, which will give you additional security at the cloud level. But for this, I don't need it, so I'll just create it. I'll go back to instances where Swift is running. Okay, it's up. Now I'm gonna attach the volume, and what we'll do then is I'll select the volume. Swift backup is listed. Okay, and it's a read write. That's it. Okay, so it's attached now. Now to connect to Swift, you have starting up steps here. Let me go back. If you scroll down on this listing, there is a link here on how to connect to the Swift dashboard. There are two things you have to do. So first is you will log in with SSH to the Swift instance or Swift VM, and you will run this command to set the initial password. And you log in with admin and then that password you set to the dashboard. And second step is taking the try image, which is our transient image used for running a pod on both sides of clusters. You have to upload this image to the respective image registry of that cluster, and so that way, and you also create one secret. It's called image pool secret in Kubernetes. So this secret is what you will tell to Swift that okay, here's the namespace in Kubernetes, here's the secret located. Use this to pull the image and run a pod. So essentially, you create this secret and register this secret in every namespace you want to replicate from Kubernetes or OKE cluster. You can look at these examples, and it also gives you how to find the Swift input from the details. Now for this example case, we are using OCIR registry, and let me show you that. If you look at the container registry, and I actually have that running in US West. So it's essentially shared registry between two, because in today's demo we are not really replicating registries or setting up DR between them, but you can do that. Essentially, the registry which you use, that's what will be used for the replication. So I have uploaded image here, and steps to upload the image are here, and this is one time step, and soon this will be automated, but this is a fairly easy step. So let's get back to the instance. This is ready, so let's connect to this. Now let's start connecting to Swift dashboard. And again, so what I have done meantime is that I completed these steps here. I connected to the instance and then set up my initial credentials using this command. So I'm gonna just log in with that. Okay, there you go. Okay, so now nothing is running obviously here, and so it will drop us on the cluster administration page because there is no cluster added right now. So let's add our production and DR clusters. So let's call it OKE production because that's what our first cluster we are adding. It's Oracle cluster. It's a production demo, and you can actually look at clusters here. This is our DR cluster. Let's look at the primary cluster. So you can see it's a OKE production demo, and then we have OKE DR demo. So we'll give the compartment and other IDs needed for this. It's located in the US West region. Yes, Phoenix region. And that's what we need. So there are a bunch of other things you can actually configure here, like when we run our transient pod, like what resources you want to use. You can always configure them later as well. While it adds it, let me show you something else. You can also go to the help and download documentation. It's very thorough documentation. You should be able to use that. Okay, so the cluster is discovered now. You can see that it has discovered all the details. Let's add the DR cluster too. Let's call it OKDR. Again, this is Oracle cluster. So OKDR demo, the details would remain same because located in the same compartment, just different region. It's the Germany, Frankfurt. Okay. Cluster ID is optional and add. Okay, so the both clusters are added. Now, as part of this namespace, I already uploaded our transient agent image into the registry used by this cluster. And I created a secret called OCI credentials, which points to that image. So if you look for this credential, like what you specify, you have to specify this here, and you can configure default for it. I'm just going to configure that. And what that does is that it will tell you where the transient container image is located for orchestration. It will pull image from there. So I'm gonna specify the image name and OCIR credentials. Just double check once. Yes, it's OCIR credentials. And that's it. We'll configure it. Let's configure the production as well as DR both clusters. Now you can actually specify this for each synchronization, or you can configure defaults. So I'm just configuring defaults, so that way it's going to pull that from the same registry. Now both clusters are using same registry, but ideally you will have a different registry. And you can set up DR policy for your container images too. Along with application, you can choose which images and versions and tag you want to sync. But I'm not going to show the image registry syncs as part of this demo. I will publish shortly a separate blocks for those. Okay, now we configured cluster. Let's go ahead and add the storage where the backups will be stored. There's no backup added. We added a separate disk for that, so we'll use that. We'll call it Blogger app pool. And you can create more than one storage pool. This is just a logical grouping, and this allows you to create backups in different on different days, because you can combine these different days. And now right now you have ZFS, but you don't need to worry about how it's managed. So this is Swift internal details. The reason it's there as a dropdown is because soon you'll have a cloud object storage option available here. So you can push your longer term backups in the cloud object storage. So SDB, as you can see, it doesn't contain any file system. You can always connect to the instance and verify this is the right disk and add it. And I'll make a default, though first pool is always default. And the advantage is it's always going to pick that pool whenever you try to do any synchronizations. Now we are done with all the prep. So it took just few minutes, and now we'll start replication. Now typically you can directly set up a DR policy and start replications, but what I'm going to do, and which we generally recommend, is that you first do synchronization explicitly, start a replication for your required application, verify that everything is okay, because sync has a lot of configuration options. You can verify those, and once you're okay, once sync works, then you can convert it into recurring sync by using a DR policy. So let's start synchronization. So we'll first back up source production application, which is our blogging app, to the storage we just configured as part of storage pool. So we'll select our production cluster. We'll select that, okay, we want to use the storage pool. Now there is no backup already here. Well, I'll call it blogger backup. So this is going to capture a bunch of volumes here along with the application objects. So this is just a logical name. You can create more than one backup, and you don't see right now, but the settings will be there as part of DR policy. You can create a backup policy, like at what frequency you want to backup. It can override the existing backup. The first time sync is going to be full sync. The subsequent syncs will only transfer what changed. It will override whatever changed. So in our case, let's go to the application. It's running as a Blogger app, and it has two microservices. Now Here's something interesting. You can select what applications you want to replicate. Like for example, I'll select blog wrap, and you can select like what applications you want. Let's say you only want one microservice replicated for whatever reason. So you can select that. Swift is going to intelligently find what that microservice is using. Is there a pod running, where it's pointing, who is running that pod, like for example a deployment, and then all the volumes used by that, all the secrets, config max. It will find that dependency intelligently and back up all of that. So you should be able to do that. For simplicity, I'm just going to back up the entire namespace. So it will back up all the microservices, all the volumes, objects, secrets, config maps, everything. Now this option try is transient RackWare agent image. So this is a transient pod which Swift is going to orchestrate on both sides of cluster whenever sync runs. And you can select, it will also run a microservice, and you can select what kind of microservice it runs. So I'm going to select load balancer because Swift is sitting in the DR and it doesn't have direct access to the production outside of the public IPs. There is no special connectivity, and this is okay because all Swift traffic, whether it's from stage one or it's whether whenever it pushes data to your DR cluster, everything is encrypted. We use VPN grade encryption. Now you can let it select two ports from the service port range of the cluster, which it will use for sync apart from the API port. But in my case, I don't have those whitelisted in between a firewall, like the firewall is running between Swift and like a production. That is OCI firewall. So I'm gonna give it two ports. So what's gonna happen is it's going to open these ports for us in the OCI firewall. But if there is any other firewall apart from OCI in between Swift and your cluster, then you have to, whatever ports you select, you have to make sure like you open those in the those all intermediate firewalls. It already picked the image, but you can always override here. You can also do dry run. It's going to show you like how much data will be transferred, what all will be transferred, but it's not going to actually transfer anything. And I'll call it initial stage one. So these jobs is just a friendly name. If you don't give it, will use name on its own, auto generated. This is useful because you can use this latter to convert into DR policy. So I'm going to start it now. So sync is running now. It will rediscover the cluster and we'll see a bunch of checkpoints. We'll also see once sync completes, we'll see how many objects it's backed up, how many volumes and data it backed up, and sync progress comes here. If something fails, you'll also see a lot of detailed checkpoints here. Right now it's taking backup of the volumes it found. So it found it using 2 volumes. So it's taking backup of those. As you can see now, it found 2 volumes and will show progress nicely here as it syncs those volumes. In source, you can see it started our microservice. Let me refresh this. You can see it has started one microservice and it's pointing to a pod. So under pods also you'll see one transient pod running, and this will use our that transient agent image which we pointed to it. And same time the source application is fully up. There is no issue here. Sync finish, so you can look at like detailed statistics like how many volumes it transferred, how much volume data it transferred. So like this is backed up in the Swift storage now. Let's look at that storage as well. Let's go to our storage pool which we created earlier. We use that, so you can see like how much data is used here. So you see some data uses. Of course, this application is small, so no, not much data uses. Also, another thing to keep in mind is Swift will use compression. So typically we see almost anywhere between 30 to 40% compression. So as you capture more data, generally we see more compression. You can also see it has captured the image group, which is the actual application backup from the sync run. It has two volumes, so it has like two images capture, two volume images. This is the full replication. So now we'll change some data and do delta sync as part of DR policy. Before that, let's do stage 2 sync. So let's go back. We'll start new replication. Now instead of this, we'll select stage 2. So since there is only one pool, of course it's going to show that. We'll select the image. Then now we select DR cluster. This is the namespace you want to select. Now here you will get all the storage classes which it found in the target or DR cluster. So you can change here like what your storage type. This is where you will also break the storage vendor lock-in from your production, especially if your production is running say on-prem and you are setting up DR with OKE. I'll just select the region. This is where volumes will be placed. And again, I'll select the load balancer for the transient RackWare service. Just select two ports. And I'll call it initial stage 2. Let's start. We started created volumes and started synchronizing those volumes. Now in this sync, it's gonna replicate the full volume. And if we run same sync again, stage 1 followed by stage 2, so only going to transfer delta amount of changes, like whatever data change, it will transfer those. Also whatever objects change, it will transfer those. Also as part of the stage 2, it's gonna replicate everything. Like it's going to create all the objects and all. So we should see those in the DR cluster. So it's right now running transient pod and service from RackWare. But you can see already the volumes are replicated here. Secrets and everything else should shortly pop up. We started replicating all the objects, so you should see those coming up here. It's also going to verify the health of applications once it's replicated. It will also do all the reconfigs, whatever you specify, like changing service types, for example. We didn't look at that, but you can do that as part of sync administration. You can configure those. And typically, let me just show those options. You can specify pre and post configs. You can specify what resources you want to use for our transient pod. You can also specify registry mappings in case your image registry endpoint changes between your production and DR clusters. You can specify that it will do that change for all the pods or containers. Similarly, you can change the service types, and you can also specify volume for exclusion. In case say you have some DB native synchronization in place, you can exclude those volumes. So it can still replicate everything else. Let's create a DR policy now. You go to the business continuity and DR menu. Go to DR policies. We don't have any. Let's create stage 1 to policy. You can also create stage 1 only policy, only backs up, Swift only backs up like application and data to its storage. And you can explicitly move this whenever failover happens, which will also provision the cluster and then restore everything. Now the provisioning cluster is not yet available. It should be available shortly. Let's create stage 1 to policy. Now stage 1 is going to back up from your source cluster to Swift, storage in Swift, and stage 2 is going to restore that backup to the DR cluster to keep it hydrated. You have a lot of options. Let's do by frequency. Let's say every 15 minutes we want to do it. You can also have like an exclude window. Now stage 2 can run with its own frequency, but I'm just gonna select run right after stage 1 every time stage 1 runs. I'll also specify my email for alerts. You can opt for like alert only on failure, or you can give it like let's call it 15-minute policy. Okay, so the policy is created. It's not applied. Let's apply it now. Now you can specify the configurations while applying the policy, but since we already ran syncs, now we can actually use those configurations from those replications. which is the easiest thing to do. Press apply. So the policy is applied. It's immediately going to start syncs. You can see that you can look at the history as well. Now you can see it immediately started sync, and then onwards it will run every 15 minutes. You can specify basically the start time. We choose to start immediately. Now you can look at the sync jobs here under active replications. You can see them. So it's running. Now keep in mind the DR setup we just did is part of the DR subscription script. So we just started script and started replicating and setting up DR policies. So that's how easy it is. So it's going to take down the target application because it will reconfigure everything. And that will happen as part of the stage 2 sync. So it completed stage 1, it started stage 2 as part of that sync run because we asked it to do back-to-back stage 1 and stage 2 syncs. And since we asked it to send alert for every sync, not just for failures, so it sent this alert. So this is how it looks. It will send you all the relevant details. While stage 2 is running now, so you'll see like everything is taken down. It's only our pod and services running, but volumes are still around, which is what it's syncing. It will recreate everything in terms of Kubernetes objects. Also for objects, you will see that all the labels, everything is retained. So sync is about to finish. We already see applications being restored, application objects. And you can see everything is restored correctly and data will now be delta synced. So we should see our new page up. Okay, sync is about to finish. Everything is restored. Let's look at the application now. You can already see our new page is up. You can also try connecting to admin interface and we should be able to use that. You can see the new post is already up. So stage 2 finished. Let's look at some replications. So policy did a bunch of replications as part of this recording. Now what I have done is I have paused the policy to demonstrate something specific what you can do with policies. Now before that, let's look at the event history. You can look at all the sync history and how it is done. So anytime you can resume policy as well. It will also show you nice stats of like what the average sync time you are getting. Now let's assume that failover event happens or the DR event happens on source side and you need failover now. So you can actually initiate that from the policy. Now you can failover all operations or specific operations. So we have applied policy only for one cluster pair. You can have more than one clusters. You may have more than one syncs applied under the same policy. You can select those. You can do drill failover. It's not just gonna do test failover. This is useful for testing. Also, the second option for stage 2. So what this will do is like let's say assume there is a stage 1 which happened. Now before it could push that stage 2, like the your source like went down, then it can force that stage to sync. So there is no outstanding stage 1. So whenever you fail over, if there is a stage 1 which has happened, it will fail over with that by completing stage 2 syncs. But if there is no stage 1 pending, it will just simply fail over with just state change. And that's helpful for testing too. Let's do the real failover. So we'll see that it's going to do one stage 2 syncs because I purposefully paused policy after it completed one stage 1 sync. but before it could do stage 2 sync. That's just to simulate the scenario where you have stage 1 happening more frequently and stage 2 is happening less frequently. So whenever you fail over, it's going to look at if there are any changes which are backed up but not yet restored on target. It's going to restore that one last time. So it's going to complete these things, and then we'll see the application again coming up on the target cluster. Again, it will take down all the objects. So it has our transient pod running, and once it completes, the application will come back up again with all the data it has backed up. So that's what we wanted to show in today's demo. So we looked at how you can go to the marketplace, launch Swift, migration and DR subscription from here, how you can use DR as a service. Then we deployed Swift. We did initial replication for OKE application, and then we converted that into DR policy. We also did a test failover, and that all shows like how easy it is to do all these kind of DR setups within minutes, and all this we did in just matter of around 30 minutes. So that concludes today's webinar demo. So with this we can open this session for Q&A now.